your mind.
Eyes, mouths, noses. We have so much in common, but a few things do vary, like skin color. It turns out there's a simple scientific explanation for that. But it doesn't explain racism. There's never a reason to treat people unequally based on their skin color. How we evolved, whether we're alone in the universe, and more. Welcome to Tomorrow Today.
It's kind of strange that we actually differentiate between black and white, because we have a lot of different tones of skin color, but what we don't have is black and white.
So what's up with race?
Humans came out of Africa about 40,000, 45,000 years ago and then moved into Europe. And they came from sub-Saharan Africa, so they had a darker phenotype that we also see in sub-Saharan Africa today. And about 5,000 years ago, they had a lighter skin color. Skin color has only recently changed. And we think the main reason why people get light skin has something to do with agriculture that gets introduced.
Johannes Krause is a director at the Max Planck Institute for Evolutionary Anthropology.
Archaeogenetics is a combination of archaeology and genetics. We analyze genetic material from the past that is associated with humans. And that can tell us something about how people in the past were genetically related to each other.
But first, the researchers analysed genetic material from the time before humans existed.
The oldest genomes that have been analyzed so far are about 1.5 million years old. They are from mammoth, from the permafrost, so from far up in the north, like a gigantic fridge where material has preserved extremely well. In conditions like in Central Europe, so we can't go back to the Jurassic, like some people might want, analyzing dinosaur DNA, but we can go back hundred thousands or maybe even a million years.
So what does all this have to do with race and skin colour? In the lab, Johannes Krause analysed bones from early humans. The DNA provided an explanation for why human skin colour has evolved over time.
Humans become food producers. They produce mostly crops from plants, like wheat or barley, and they become almost completely vegetarian. So the early farmers that lived here 4,000 or 5,000 years ago, they didn't eat a lot of meat and fish. And that actually causes a problem living in Europe, because Europe is very dark. And if you are vegetarian and you have dark skin, they become vitamin D deficient in the winter. Because as we know, sunlight can produce vitamin D in the skin, but if you have dark skin, you produce less vitamin D than if you have light skin. It basically happened parallel in several places that people became light, but it's not that those people are closer related, like East Asians, for example, and Europeans. That is a very recent phenomenon. So it really doesn't make sense to differentiate human populations based on their skin color.
OK, so a few mutations account for the variation in human skin colour. And that's why there's racism? Scientists have long known that the DNA in all modern humans is 99.9% identical, and there are only minimal differences in the rest. So what we call race doesn't have a genetic basis. The term is often used as a tool of power and oppression.
I do think that racism exists everywhere in the world. So this is not just a European problem that we have on all continents. At the end, it's about property and about power, and those dynamics exist everywhere. There's this fantastic experiment in like school classes where you give half of the people blue shirts and half of the pupils red shirts, and then very strange group dynamics form, or football fans, or the neighboring village, or there are many such types of where you alienate, where you kind of see foreign groups easily. I think culture overcomes that. We don't have to follow our instincts. We're not animals. Our phylogenetic tree is based in Africa. There's basically the tree, the trunk, the thickest branches are all in Africa. And this is tiny genetic diversity that we find outside Africa, but all the major lineages are inside Africa. So actually genetics, like no other discipline, from my point of view, has actually disproved the concept of races.
So early humans came from Africa. But how did those first humans live? And what did they eat? To find out more, scientists are studying the traces left behind on prehistoric tools made of stone.
This is roughly what the first humans looked like 2.5 million years ago. These earliest humans were already skilled in making stone tools. Here in the Ethiopian highlands, archaeologists discovered a trove of stone tools dating from about 1.6 million years ago. For more than 2 million years, our early ancestors used tools made of stone in their day-to-day lives. These stones are among the few remaining artifacts that offer insight into the lives of hominins, early humans. At the Leibniz Center for Archaeology in Neuwied, Germany, João Moreiras is studying identical copies of these tools. He wants to determine what exactly early humans did with these tools. For example, was this flint blade used to saw wood? This robot will help answer that question.
When we work different materials, the edges that are used to work those materials, they are characterized by different types of damage, like the knives that we have at home. And those damage that we can only see at the microscopic level, they are diagnostic of those work materials. So if we recreate this damage in a lab, then we can compare it with the damage that we see in the artifacts.
And that will reveal what the tools were used for. The archaeologists here want to help bring a bit of order into the toolbox used by early humans. Stone tools, for example, were used to break open animal bones. Bone marrow was an important source of nutrition in the prehistoric diet. In this device, the stone is being smashed into an aurochs leg bone. It's hard work, which is why early hominins would have used stones that would make sharp and durable tools. Ivan Kalandra is carrying out what's called a use-where analysis, which will help identify what a tool like this was normally used for.
You can see these nice shell-like shapes that have splintered off, which are diagnostic for how it was used. This was used on wood, right? If the original prehistoric tools display the same signs of wear, that will help prove they were used to saw wood.
Archaeologist Sabine Gaudzinski-Windhäuser heads the research project that aims to identify how such early stone tools were used. It's an ambitious undertaking.
Use-where analysis has been around since the 1980s. Various laboratories were involved around the world, and each lab used its own reference framework. So the results they came up with aren't necessarily comprehensible for the entire research community. What we're doing here is trying to identify standards that will allow us to turn this kind of use-where research into a proper archaeological subdiscipline.
The Institute also has an electron microscope. Ivan Kalandra will use it to examine the stone sample that they used to try to break open the auroch bone. The structural damage on the stone is a kind of fingerprint that can reveal what use the stone was put to.
There are lots of fine cracks here, which must have come from the impact.
Another piece of information that will help create order in the Stone Age toolbox. Tools made of stone were used by early humans for more than 2 million years. And that means experimental archaeologists have their work cut out for them.
Modern technology is helping us to look out deeper and deeper into the universe. What will we find? And would we be prepared for an encounter with extraterrestrials? It might sound like science fiction, but it's something scientists are thinking about. Because there's a good chance that somewhere out there are alien forms of life.
Just imagine one day a UFO appears overhead, or an extraterrestrial being makes contact from a nearby planet.
That would be one of the most exciting days in human history, a day we've been waiting for thousands of years.
As NASA science administrator, Thomas Zurbuchen gave thought to how such a first contact with alien life might play out.
At NASA, we had various scenarios. It all depended on what we found, where we found it, and how intelligent the life was.
However that first contact took place, the first job would be to inform everyone about the discovery.
We have all sorts of communications channels to draw on. If we were being threatened from outer space, we'd first let every country in the world know, especially if it affected them, like in the case of an asteroid. The international communications channels already exist, so that's what we do.
And what would a first contact lead to here on Earth? If we were to discover we're not alone in the universe, we'd have to rethink our own conception of ourselves.
If aliens landed here tomorrow, most people would find that pretty unsettling. For one thing, we'd have to assume that their civilization is much more advanced than ours, because they found us, we didn't find them.
But discovering alien life in the universe wouldn't have to be scary.
For people who aren't religious, it might be comforting to imagine that the universe isn't just a cold, empty place, that there's life out there, maybe even a kind and loving form of life.
And what might that first contact look like? There are several scenarios for that too. One possibility is that we receive a signal from outer space. But a cosmic dialogue is unlikely. Our galaxy is about 100,000 light-years across, and the nearest major galaxy is 2.5 million light-years away. So that's how long our reply would take. A second scenario, the aliens come to us. Of all the options, this would probably have the biggest impact. Did they come in peace? Can we communicate with them? And who would speak in the name of humanity? A third scenario, we find traces of alien life ourselves, like bacteria or other organisms. That's conceivable on Jupiter's moon Europa. It's made of ice and possibly also of liquid water, which tops the list of ingredients necessary for life. In April 2023, ESA launched its JUICE probe toward Jupiter to investigate. Whether it's little green men from Mars or humble bacteria, for science, the discovery of alien life in the universe would have major implications.
It would be huge. Right now, there's one kind of life. All life on Earth is related. So are there other branches of life out there? If other life exists, maybe we could use it for new medications or new solutions to problems. There would be all sorts of possibilities we can't imagine today.
But learning from alien life might not be all that easy.
One question is, would we even grasp what they're doing? The philosopher Immanuel Kant said that we humans are so narrow-minded that we always imagine aliens to be just like ourselves. We can only imagine what we know. When children draw aliens, they might be green, have 3 eyes and 7 arms, but they're still creatures with a head, arms and legs.
We still don't have proof, but scientists believe the question is not whether we find alien life out there, but when. For now, though, the circumstances surrounding our first contact will remain in the realm of fantasy. And imagining that first close encounter with alien life is something we're pretty good at.
Scientists think life here on Earth began in water, but liquid H2O only forms under certain conditions. In 2005, though, a space probe did find evidence for ice on Mars, an amazing discovery, and one aspect of the answer to this viewer question, which comes from Calixto S. in Colombia.
Why are scientists more interested in studying Mars than the Moon? Mars is Earth's closest planetary neighbour. It's further away from the Sun than Earth, and Mars is the only other planet in our solar system where humans could survive, in theory at least. For example, Mars has a daily cycle that's very similar to Earth's. A day on Mars is 37 minutes longer than here at home, so our biological clock wouldn't have to adjust all that much. But on the Moon, the solar day is 29.5 Earth days long, and surface temperatures on the Moon vary hugely in sunlit areas compared to in the shade. That's because, unlike Earth and Mars, the Moon doesn't have an atmosphere, so there's nothing to help regulate the heat and cold. And light conditions on Mars and Earth are also similar, which is why there's a sunset on both planets. And the rotational tilt of Earth's axis is almost identical to that of Mars. All of that means their atmospheres share some similar features. In comparative planetary research, the atmosphere of Mars is like a simplified model of Earth's atmosphere. Earth's atmosphere is mainly nitrogen and oxygen. It's the only planet in our solar system with liquid water on its surface. About 3.5 billion years ago, there was also liquid water on Mars, as these river valleys show. Back then, the climate on Mars would have been more conducive to life, and its atmosphere denser. But then, Mars lost most of its atmosphere. Strong solar winds, charged particles from the Sun, blew away most of Mars's upper atmosphere. Earth's protective magnetic field helps shield it from the solar winds. Today, the atmosphere on the surface of Mars is only about 1% as dense as Earth's, and Mars changed from a hospitable planet to the dry, cold one it is now. Today, water on the surface of Mars is either ice or vapour. There are also 2 permanent polar ice caps here. Beneath the surface, there's also plenty of this essential resource, which would be crucial for any manned outposts here. In early 2022, Europe's ExoMars Trace Gas Orbiter spotted what appears to be vast reserves of water ice under the Valles Marineris, the Grand Canyon of Mars. Simulations are underway to see whether an artificial magnetic field could make Mars more hospitable to life as we know it. Atmospheric pressure and temperatures would increase until the carbon dioxide and water ice at the North Pole would melt. And that would trigger a greenhouse effect that would transform the underground ice into rivers and seas. The technology isn't there yet, but it might be possible, at least in theory.
If our blood is red,
do you have a science question? Then send it to us as a video, text, or voice message. If we answer it on the show, we'll send you a little surprise as a thank you. So come on, just ask. Along with Mars, scientists are focusing on another celestial neighbor, the Moon. The most recent Chinese mission to our natural satellite, the Chang'e 6, has returned moon rocks and dust from its far side to Earth, a milestone achievement. One major challenge for any mission to the Moon is getting there. There are many potential problems, especially when it comes to landing. Even so, more and more organizations and companies are looking to make the journey.
2, 1, ignition.
On February 15th, the US-made Odysseus probe was launched to the Moon. It was the first time a private company flew to and touched down on the Moon. Odysseus made a lopsided landing, but it still sent data back to Earth, as NASA and Intuitive Machines, the lander's owner, confirmed. Odysseus, or ODI for short, kept working for about a week, until it lost power when the Moon's south pole went dark. Good night, ODI. We hope to hear from you again, the company Intuitive Machines posted on X.
When the Moon went dark, it couldn't produce solar power anymore. So they did a controlled shutdown, hoping that after the Sun returned, about 2 weeks later, the lander might have enough power to start up again.
A lunar night lasts about 14 days. That will be a problem for future long-term missions.
The moon rotates more slowly than the Earth. We complete a rotation in 24 hours, which is why we have 12 hours of night and 12 hours of day on average. The moon completes a rotation in a bit more than 28 days. That's why its nights and days are so long, longer than 14 Earth days.
Current moon missions are facing another challenge. The Apollo missions of the 1960s and 70s all landed near the equator. But now the probes are aiming for the moon's south pole, and plans call for landing astronauts there in 2026.
The most straightforward trajectory from the Earth to the moon follows the moon and Earth's orbital path around the sun. Then you arrive at the equator. To land somewhere else, the engines have to put you on a different trajectory. That's more complicated, more costly, and takes more fuel. Those are things you normally try to avoid in spaceflight.
Last year, several countries set out for the moon with varying results. India's Chandrayaan-3 probe made a successful landing. Russia didn't succeed. Even today, moon landings are still feats of technology and engineering.
First, the probe has to carry out a precision landing. Second, there's no atmosphere there to slow down the landing. When a parachute descends here on Earth, it's a very gentle landing. That doesn't work on the moon. You need jet nozzles to slow you down. If something goes wrong, the whole thing crashes to the ground. That's happened several times already.
There's another problem. The shadows on the moon are very dark.
On the moon's south pole, the sun lies flat on the horizon, so you get fairly long shadows. But the navigation devices need to be able to precisely locate the ground. That can be tricky in dark areas. Plus, shadows on the moon are darker than on Earth, because there's no atmosphere to scatter light into the shadow. Those long, deep shadows on the South Pole make landing difficult.
This is the Argonaut. ESA is also planning to fly to the moon with its Argonaut lander. But that's still a few years off, which will allow the agency to learn from other successful landings and unsuccessful ones.
Argonaut is the first probe that was entirely developed by ESA. It's scheduled to land on the moon in 2030 or 2031. That mission will be led by Germany, within the framework of ESA. We're going to bring freight from the Earth to the moon, a relatively large amount of freight, 1.5 tons.
In 2018, NASA announced it was setting up a sponsorship to encourage the development of commercial payload services to the moon. Back then, the idea seemed like a stretch. Intuitive Machines also wouldn't have made it to the moon without NASA's help. During the landing approach, there was a problem with one of its rangefinders. At the end of its long night on the moon, Odysseus didn't wake up. On March 23rd, Intuitive Machines posted on X, "Our IM-1 mission ended 7 days after landing."
There are other ideas out there for how to make the journey into space more cost-effective and accessible. One is to use candle wax as fuel instead of expensive liquid propellants. Now that really is rocket science.
Light this candle. That's what Alan Shepard said in 1961 when he was waiting impatiently for his first launch into space. It's also the name of the mission of the first test flight carried out by a company from Germany. They lit their candle in May 2024. They didn't make it into outer space, but for the startup High Impulse, the launch was a success. It was the first time that a rocket had been propelled by paraffin, or candle wax.
The rocket contains solid paraffin, which is basically candle wax. Cold liquid oxygen is injected into long channels that have been drilled into it, and the entire thing ignites. The burning paraffin yields a very hot gas, which delivers a lot of propulsion to the rocket.
Paraffin doesn't catch fire easily in regular air, and when it does, it burns very slowly. That's why there's next to no risk of explosion, and that means the rocket can be transported safely, even when it's loaded with paraffin fuel. After the launch, the rocket was recovered from the test range so that its post-flight data could be analysed. The SR-75 model tested in early May wasn't powerful enough to reach orbit, but the SR-75 is designed to be able to spend a short time in outer space before falling back to Earth, together with its cargo. Those flights are mainly suited for microgravity experiments and atmospheric research.
That could be, for example, physical experiments, pharmaceutical or biological experiments, material sciences. Those kinds of flights have a range of uses.
High Impulse is working on its next model, the SL-1, designed to deliver payloads of up to 600 kilograms to low Earth orbit. It will also use a hybrid rocket motor, making it an affordable alternative for small satellite operators.
That's all we have time for now. But thanks for joining us, and hope to see you again soon on Tomorrow Today. Bye-bye.